Hello, everyone. Welcome to Developmental Psychology, DEP 2004. I am Dr. Rivera. Okay, everyone, in this video, I'm going to begin talking about cognitive development, and I'm going to begin with Piaget. Now, we already talked about Piaget a little bit when we talked about cognitive development in infancy, but now we're going to talk about early childhood. During infancy, up until around 2 years old, children are in the sensory motor stage. And we went over the idea that the most important part of the sensory motor stage is that children cannot control their minds. They can't force themselves to remember something, but over those first 2 years of life, they start to internalize a lot of information. So they're taking in a lot of information, but they can't really control too much. So that by the time the sensory motor stage is done, they have just started to utilize all the information they've learned in order to put it into work, to make plans, to have ideas, and obviously to speak. Children begin to speak at around 1 year old. Usually that's one word, two words, but little by little, they start to develop more and more complex language as well. By the time the child is in their pre-operational stage, they already have a lot of understanding about the world. They've already been talking for a little while. The pre-operational stage, what's happening is that now the child has the ability to think on purpose. You can ask them questions and they can give you answers that directly relate to the question that you asked. And by the time a kid is around 3, you can ask them, what did you do yesterday? What did you do last week? And they're better able to give you the correct answer, right? That is, they're able to say, yesterday I did this, last week I did this. But of course, the biggest problem is that their logic is not very good at the pre-operational level. And so it's during this stage where kids are learning sort of the number principles, and that takes a while. They have private speech, which is when children talk out loud as if though they're speaking to somebody else, but in reality, they're just talking to themselves. And they might say things, maybe we should put the block on top of this tower. And it sounds like they're talking to somebody else, but in fact, they're speaking to themselves. But they have a hard time doing complex logical reasoning. And the reason that they have a problem with that is because a lot of things interfere with their logic. If everything is perfect, sometimes these kids can have a logical leap and get to the right answer. But most of the time, what's happening is that certain things are blocking their ability to be logical. And you'll see in that third column where it says interfere, you see the phrase centration, appearance is reality, animism, artificialism. These are all things that block or prevent children in their pre-operational state from having logical thoughts. And I'll go over those one at a time. Now, throughout this period, these children are not going to be able to do conservation, which I'll talk about also, reversibility, transform ideas forward and backwards. That's very difficult. As I mentioned, logic gets blocked a lot. Combine ideas, separate ideas. It's very difficult for children in their pre-operational stage to do this. When my niece and nephew were in this stage, sometimes I would explain to them that I am, in fact, their mother's brother. And that was very difficult for a child in the pre-operational stage to accept, because that means they have to break apart some of their ideas, right? They have to go, no, my mom is my mom. But, oh, so you are related to my mom the way I'm related to my brother. That's very difficult for a child, especially early in their pre-operational stage. I'm also going to show you a little bit, at least one of the videos that I'm going to post is of a girl in their concrete operational stage. So you can compare their ability to do logic. And then later on, we'll talk about the concrete operational stage and the formal operational stage. Now, as I mentioned, by the time a child is 1, they are already talking. And by the time the child is 2, they're probably even putting sentences together. Um, During their preoperational stage, children's symbolic thought gets much more complex. And in fact, now children can do things like draw a picture of a stick man or a stick woman and say, this stick man is dad, and this stick woman is mom. That is, they understand that that drawing is symbolic or represents something else. They're not always great at doing this, but they certainly can do it, and they're starting to do it more and more easily. Also, during this stage, there's more and more symbolic play where children will either pretend to be somebody else. We're going to play mom and dad. You're the mom, I'm the dad, and Tommy's going to be the baby. And now we're all supposed to pretend that we are these individuals. This requires some cognitive sophistication. And in fact, researchers think that this has to do with the child's ability to control themselves. If you have to pretend to be mom for the next 10 minutes while we're playing, well, that takes a lot of self control because now you can't react the way you react. You're trying to react the way moms react, right? And so playing with that allows a child to become more sophisticated in their thought process. And it also allows them to have more self control. So, in fact, playing is a really important part of learning to be older and to control your mind and your thoughts. Now, one of the things that interferes with a child's ability to think logically is egocentrism. Egocentrism means that the child cannot put somebody else in the center of their thought process. They only think the way they think. And in fact, early on, children don't even know that other people have different thoughts than they do. They assume everybody knows what they know. And I'll talk a little bit more about that in a separate slide. But I do want you to watch the video of the child who is doing the mountain task. When this little kid sits down at first, or the adult sitting across from him asks him, what do you see? And at first, the child says, I see a cat, and I see a tree, and I see a bone. And so then they switch seats. The adult and the child switch seats. And now the adult asks the child again, what do you see? And the child says, well, I see an owl, a goat, a tree, and another tree. Now, the real interesting part is what the adult asks next. She says, what do you think I see sitting over here? Now, a child who is older than the pre-conventional stage, if a child is at the concrete operation level, they would be able to imagine what the woman sees, what the adult sees. And they would say, I see an owl and a goat and a tree, but you are probably seeing a cat and a tree and a bone. But of course, the child at the pre-operational level doesn't do that. They assume that because uh, they see or he is seeing an owl and a goat and a big tree and a little tree, that the adult also sees them. And you'll see him say an owl and a goat and a tree because he assumes that whatever he is seeing is also what she is seeing. Now, the children in the pre-operational stage, we often say they're pre-causal. Pre-causal reasoning occurs when the child doesn't consider that certain things happen naturally, that there's a natural cause and effect of certain situations. And they tend to assume that things happen specifically for them. Why? Is it dark outside? And a pre-causal child or a child at the pre-operational stage might say, so I can go to sleep. They are not trying to think of the world logically. They are only think of the world in relationship to them. And so things that have nothing to do with them, they just assume that they must have something to do with them. And again, this interferes with their ability to think logically and sort of to make reasonable arguments or have reasonable thoughts. Transductive reasoning, it falls almost right in line with that. In transductive reasoning, what happens is the child sees something happen, one event, and then they assume that another event that is similar, well, I should be able to use what I learned from the first event into the second event. So let me show you an example of that. Let's say a little kid blows a book and a bunch of dust comes up, right? And so they assume they understand that because they blew, the wind from their mouth blew all the dust away. Well, later on, they might see some leaves floating around and the wind blowing them around. And the child might think somebody must be blowing on the leaf because they're not thinking about the world naturally or scientifically. And their logic is not really following any kind of logical or reasonable way of thinking. They are just comparing what's happening now to what happened before and assuming that they must be the same thing. Because when I blew on the book, the dust flew away. Well, all the leaves floating away, it must be that somebody is blowing on them. Now, in your test for this section, you won't see inductive or deductive reasoning, but I want to give you an example of inductive and deductive reasoning so that you can compare it to transductive. In inductive reasoning, what happens is you see a bunch of different things that are related or similar, and from the many different situations, from the many observations, then you develop a theory or a hypothesis or a conclusion from everything that you saw. And so imagine that there's a bag with something in it, and you pull one of the things out, and it's a penny. And then you pull something else out, and it's also a penny. And you pull something else out, and it's also a penny. And you might uh, reason that all of the things in the bags are pennies, right? Because the first three things were pennies. And you are taking that data and trying to develop a hypothesis based on that. Now, it's not always the case that inductive reasoning leads to correct answers, but it's certainly better than transductive reasoning, which is what preoperational children are doing. Here's a second example for inductive. Um, your friend Penny has an A in math, has an A in science, um, and you might assume that, well, Penny is a straight A student, but it makes sense for you to think that because all of the first observations suggest that that is true, that Penny is a good student or is a straight A student. But that's not always the case, right? Every once in a while, a straight A student might do very poorly in one assignment or one class in general. And so inductive reasoning is certainly better than the transductive reasoning that children are doing during their pre-operational stage, but it's not perfect. Now, deductive reasoning takes some theory or hypothesis that you know to be true, or at least you think is true, and then you take that data and apply it to a new situation. Or you take that rule or hypothesis or theory and you apply it to the specific situation. For example, you might get this rule: A equals B and B equals C. So if that's true, then what can we say about C? What does C equal? And you might say, well, then C has to equal A. A child in their pre-operational stage could not do this. This is much too complicated. However, I also like to point out that deductive reasoning tends to do well. It's a good way to And you might think, well, granddads are bald. And then you see your professor is also bald. And you might think, well, then my professor must be a grandpa, right? You see here how because the first rule was not correct, now you're applying it. And so here's an example that is closer to being true. Um, Germs cause infections. And so then you say, you see a wound and the wound looks bad or it doesn't look like it's healing. And you might say, well, since I know this theory that germs cause infections, then I'm going to assume that your wound is infected with germs. And so, we're going to clean it out uh, and try to kill those germs. In this case, because the rule is true, when you apply it, then your deductive reasoning turns out to be true as well. In good science, good reasoning in general goes back and forth between deductive reasoning and inductive reasoning, right? Scientists and researchers use these back and forth because it allows them to come to better conclusions. But of course, what's important here in this chapter is that children in their preoperational stage cannot do deductive reasoning and they cannot do inductive reasoning. They do this transductive reasoning where they assume that. Now, going back to that pre-causal reasoning for children, where they don't consider any scientific thought or logical thought process to understand why things are happening, they usually assume that inanimate objects have qualities of living things. Now, technically speaking, a child who is 3 and 4 and 5, they know that the plush bunny isn't alive. They know that the plush bunny isn't going to get pregnant and give birth. They know that the plush bunny doesn't have to eat. They know that the bunny doesn't have internal organs or blood, right? Children at this age have a good sense of what makes something alive. And yet they can't help themselves but to assume that some inanimate objects still have the traits of living things. This is why a little kid who bumps themselves against a table might think that the table is being naughty and they might want to spank the table. Or that if their dolly or their Mr. Bunny falls, they might think, oh, Mr. Bunny, he hurt his head. Because even though they understand that Mr. Bunny isn't alive, that the table isn't alive, they still assume that they have some form of living qualities. Artificialism also goes right into precausal thinking. In artificialism, children assume that everything must have been made by a person. And so a child might ask you, who put the moon in the sky? Or who made that mountain over there? Because again, they assume that everything in their life must have been made by somebody else. They are not considering at all that some things were just here, or they're natural, or that there are forces that form them, gravity, or I don't know, erosion for things like a mountain. Also, during this stage, children have a hard time distinguishing their thoughts from reality. And again, we kind of go back to this idea. You sometimes ask children in their pre-operational stage, what did you do yesterday? And they might embellish a whole lot because not because they're lying, not because they wanted to deceive you, but in fact because they had these thoughts and they don't know how to separate their thoughts from what actually happened. This is why children, for one, make horrible eyewitnesses because children don't have the ability to differentiate what they saw, heard, or did with whatever someone told them or whatever they thought, right? They don't know how to separate their mind from the real world. During this stage, they have a very hard time thinking about things that are not directly in relation to them. Now, There's another video that I want you to watch, and that is the one for centration. And you'll meet three little girls. Two of them are there in their pre-operational stage, and one of them is just a little bit older. One of the things that interferes with logic in children is what we call centration. And centration means that they can only focus on one thing at a time, one variable at a time. And in order to do certain tasks or think logically under circumstances, you have to hold multiple variables in your head. And if you can't do that, then you can't do that logical thought process. For the first little girl in the overalls and the pink shirt, the adult showed the child two beakers with juice in them. And then she asked the child, which one has more? This one, or do they both have the same? And when they're both in the beaker, the little girl says they're both the same. But then the adult takes one of the beakers and pours it into a cylinder, a thin cylinder. And so now um, she will ask the child, which one has more? This one in the beaker, this one in the cylinder, or do they both have the same? Now, mind you that the child saw the adult pour the juice, and the child earlier distinguished that in the beakers, the juice was the same height. But now that one of them is in the cylinder and the other one is in the beaker, they can't hold on to multiple variables. And they just see that the cylinder is higher, it's taller. And they'll say, the cylinder has more juice. And when you ask them why, they're going to tell you because it's taller. Now, the young girl in the pink jacket, she's in her concrete operational state. And when the adult pours the beaker or one of the beakers into the cylinder, you'll notice that she doesn't even hesitate. She says, they're both the same. And when the adult asks her why, well, that takes a little bit. She has to put that into words, and it's a bit of a hard concept. And so she says, you know, this one is wider and this one is thinner, but they're both the same. You'll notice that explaining it takes her a little bit, but the actual mental task is almost immediate. She said immediately, they're both the same, right? Because she can remember that originally they were the same when they were in the beaker. And now, because she knows that the cylinder is thinner and it's displacing the water differently, it just looks taller. But in reality, it's the same amount of water. Now, the young girl in the, I'm going to go with mint shirt, she is also in the pre-operational stage. And they put two rows of quarters in front of her. And they ask the child, which one has more, this row or this row? And the little girl counts them 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. And she goes, 5, 5. They're both the same. What you see there is that this little girl has a great tool to utilize in order to figure out which row has more. She counts them. And then the adult right in front of her will spread one of the rows apart. So now the quarters, there's still 5 of them, but they are further apart from one another. And now she'll ask, which one has more? The line of quarters that are sort of stuck together, the line of quarters that are spread apart, or do they both have the same? And now the little girl, who just earlier counted them, now she says the bigger one or the one that has space in between. Why? Because it's bigger, because it's longer. Because she cannot hold multiple variables in her head, then she just chooses the one that is simplest to understand. She goes, well, the one with the extra space, that one has more quarters because it's longer. As the child leaves the pre-operational stage and enters the concrete operational stage. Now, another thing that children will be able to do in the concrete operational stage, but during this stage, they have a very difficult time doing, is categorizing things in multiple ways. so that I might say, I want you to put these toy cars and these toy motorcycles into groups. Separate the motorcycles from the. And a child at this stage might be able to do that, especially as they get closer to 7. They're going to find it easier to do that. But until they're around 7, 8, 9, they'll have a hard time with this class inclusion portion, right? So I might say, how many vehicles are there? Um, and it's hard for the child to go, well, both cars and the motorcycles are vehicles, and so I have to count them all. Usually what they'll do is they'll just count one of the categories and say that. And then you might ask, well, how come you didn't count the motorcycles? And they're just going to say, well, because they're not cars. That idea that one thing, right, motorcycles can be categorized as motorcycles, but they can also be categorized as vehicles. That's a little too complicated for them. Now, you'll also see a couple of other videos where researchers are studying the ability of sometimes infants, but certainly children, to determine how well they understand physics or biology. A child doesn't actually know physics, but they understand aspects of physics. So we call this naive physics, right? The ability for a child to understand that if you drop something, it should fall. And if it doesn't fall, the child gets very surprised that it didn't fall. Or that if I put an obstacle in a track and I let a car run, a toy car run through the track, the car isn't going to be able to go through the obstacle. It'll stop. But if I can do some sort of magical trick where I make the car go through the obstacle, you'll notice that the child is quite surprised by that. And they will scrutinize the situation. And sometimes they might even like make noises because they don't understand how this happened. They know the laws of physics for a child, and they cannot imagine why this car didn't follow the rules of physics. The same thing is true with biology. Children understand certain aspects of biology. And again, we call that naive biology, where children understand that things that are alive move and things that are alive grow, and that they might inherit certain aspects from mom and dad, or that they have internal parts, internal organs, and things like that. That if they get hurt, they could potentially be healed. And yet, knowing all of these things, children in their preoperational stage are still confused by things like centration and animism and artificialism. All right, now we're going to talk a little bit about some factors in cognitive development, where Piaget believed that cognitive development was just a part of maturation. That is, you got smarter because you're getting older. Researchers like Vygotsky didn't think that, and they believed that you get smarter because there are older people or more knowledgeable people who help you or guide you to be smarter or more capable. And oftentimes we call this scaffolding. When a teacher explains something to you, what they're trying to do is scaffold it for you, to sort of build a bridge from where you are to where you need to get to. Now, scaffolding is quite sensitive the way you do it. If you don't explain enough, if you don't scaffold enough for a child, the child might get overwhelmed and then they'll stop doing the task and they might even learn to hate the task. But if you give them too much instruction, they might get bored or they might start to think, this is way harder than I thought, right? Here's a teacher explaining something more and more, and oh, it must be that this is really complicated, the child might think. And so if you scaffold too much or you don't scaffold enough, either one of those can make the child less interested and less capable of doing the task. I'm sure you've had the experience of being in a classroom and the teacher is explaining like a project and you're listening to the teacher go on, and you start thinking to yourself, how am I going to do this? This is too hard. And eventually, after you're done or after you see somebody else do their project, you think, oh, that was so simple. Why does she make it sound so complicated? Well, because she's trying to scaffold the information for one of your classmates, a classmate that maybe isn't as quick or felt lost, but because you got it right away, all that extra scaffolding that your teacher did now just feels like maybe she's explaining something I don't understand. And so you start to get scared, and oftentimes you don't quite learn what you're supposed to. Now, the zone of proximal development is also something that people have a hard time with, and you're going to find it in your packet and in the test. So I want to go over it here. Your zone of proximal development is the limit to your knowledge, right? If you know how to bake one of those instant cakes that you buy in a box at the supermarket, right? They tell you add eggs and oil and then just put it in the oven. You know how to do those just fine. But now if I ask you to make a cake from scratch, well, you don't know how to do that, right? You're at the limit of your knowledge. You're at your zone of proximal development. And at this point, you need an adult or a more knowledgeable person to scaffold the information from what you know to where you need to get to. Now, in this world, a lot of times that scaffolding is just something on YouTube, right? I'm sometimes doing like handy things in the house and I don't know how to do this or I don't know how to do that. And so I'll go into YouTube and they'll explain it to me. And because my knowledge is at its end, I need to use their information to help get me to that next stage. Let me give you a more visual example here. Let's say that the child knows how to add single digits, right? And so you're going to see here 7 plus 6. Well, this kid knows how to do that. And so they're going to go 7 plus 6, that's 13. But now you want to make it a little bit more complex for them. And so you give them a number with 2 digits in it. And so here we have 17 plus 6. Now this child is at their zone of proximal development. How do we know that? Because we know that this kid only knows how to add single digits. They don't know this next step. And a lot of times when they don't know the next step, they'll sometimes do things like this. 7 plus 6 is 13, and I'm going to write 13 down there. And then 1 plus 0 is 1. And so now it looks like 17 plus 6 is 113. Obviously, that's wrong. An adult or an older child needs to scaffold this for the learner. And so usually what the teacher will just explain is that he has to carry the 1. So 7 plus 6, that's 13. Well, the 3 is in the ones place, but that 1 is in the tens place. And so you got to add it to the tens place. And so now 1 plus 1, 1 from the 13 and 1 from the 17, that equals 2. You have to show children this a few times and then they just run with it, right? This isn't super complicated for the child. But without the information from the adult, the child would stay stuck at 17 plus 6 equals 113 because they are not going to be able to figure out how to carry all on their own. They need an adult to do that for them. I want to show you here these 2 ladders with the plank between them. That is what we call a scaffold, right? That's the imagery that we're trying to convey. The adult is trying to get you from one of these ladders to the next one by teaching you how to do that specific thing. Now, I've already talked about egocentrism, so I would like to talk about theory of mind, which goes hand in hand with egocentrism. Now, I don't love the term theory of mind or theory of mind mechanism because it kind of sounds like the scientific theory of mind, and that's not what it is. Theory of mind is the child's theory. The child is developing a theory about how the world works. And specifically, they're developing a theory on the fact that other people have minds of their own. Before around 4 years old, children can't do that. They assume that everything they know, you know too. And every once in a while, you might be explaining something, and a child who is, just younger than 4 might say to you, "That's not how it went." Um, and then they explain how it went, and they say the exact same thing you did, but they use like one different word, or they highlight one specific thing, because first of all, they don't understand that you saw the world differently than they did. And they can't assume that you would explain the situation differently than they would explain it, because they don't know that different people have minds of their own. And we usually test this with a false belief task. And again, there's a video that you can watch here. The adult says to the child, "What do you think is in this box?" And the child says, "Crayons, obviously." And then the adult will open up the box, and the box is full of candles. Now, when the adult closes the box again, he'll ask the child again, "What's in this box?" And now the child knows, and he'll say, "Candles." And then you can ask him, "What did you think was in the box earlier?" And the little kid is going to say, "Candles. I always knew it was candles," right? Because not only do they not understand what other people think, but they have a very hard time understanding that their mind has changed with a new knowledge. And so in fact, they're just going to say, "I always knew it was candles." I could take it a next step level, and I'll say to the child, "You see Snoopy over there?" You'll see that they use Snoopy as an example. "You see Snoopy over there? Snoopy has no idea what you and I have been speaking about. So I'm going to ask Snoopy what he thinks is in this box of candles. What do you think Snoopy's going to say?" And a little kid who's younger than 4 is going to say, "Candles," right? Because the child knows there's candles, and they cannot imagine that other people don't know what they know. By the time a child is around 4, they're able to do that task. And not only are they going to be able to tell you, "Earlier, I thought it was filled with crayons, but now I know that it's filled with candles." But they're also going to be able to do the more complex task of saying, "Snoopy is going to say that the box is filled with crayons. Why? Because it's a box of crayons. So the Snoopy's going to make the same mistake I did." Now, going back to pre-causal thinking, another thing that interferes with the child's ability to logically is that they don't quite understand why they know things. If you tell a kid, "Put your hand in this box," and the child can't see what's in the box, they can only feel it. And they might feel in there and say, "Oh, it's a ball." And then I might ask them, "What color is the ball?" And they're going to say, "Blue." The child in their precausal thinking doesn't quite get that there's no way for you to see color or know color just by touching it with your hand. You need your eyes in order to make that determination. But really, it's not until around age 4 that children understand that I would need to use my eyes to see the color. And in fact, I'm just holding the ball. My hands cannot see what color it is. And again, I kind of mentioned this already, but this is one of the reasons why children make bad eyewitnesses. They don't understand that something that they didn't see, they don't quite understand that something that somebody else said doesn't mean that they saw it too. And so if I say around a 4-year-old that I think Lewis stole some money, when you ask that child, "Did Lewis steal the money?" He's going to say, "Yes." "How do you know?" "I just know. I saw him, or I remember him," because they cannot separate what they have learned through just speaking versus what they have actually experienced. And so they will speak about something that they only heard as if though they had actually seen it. And again, going back to that sort of pre-causal thinking, another thing that interferes with a child's knowledge is the feeling that appearance is reality, right? If you put on a mask in front of a child, and especially if the mask is scary, the child is going to cry. Now you could take your mask off and say, "Hey, look, it's me." You don't have to be scared, and then they'll calm down. But when you put the mask on again, they're going to start crying again because they believe that whatever they're seeing, that must be what's true. Another example of this is sometimes a child will say that they want chocolate milk, and they'll serve themselves just like regular white milk, and then they'll put on sunglasses. And because the sunglasses make the milk look brown, they think that in fact the milk is chocolate milk now. And they'll drink it and say, "Yum, I love chocolate milk," because they don't know how to separate reality, what's actually real, from what it looks like. All right, everyone, thanks for watching. Let me know if you have any questions, and remember that the best way to contact me is directly through Canvas. I hope to hear from you soon.